In case of a computer failure, the second computer of the same type takes over, ELAC, SEC, and FAC cases. Note that SEC-3 is only used for spoiler control and does not participate, as do SEC-1 and 2, in the flight control system reconfiguration. Each primary flight control surface is supplied by two separate hydraulic systems, for instance, ailerons, elevators, and stabilizers. The rudder is supplied by all three systems. Each control surface has an independent actuator for each hydraulic source. Each actuator is controlled by a different computer. One actuator for each surface is always in active mode. The other stays in damping mode and is monitored by its associated computer. We will demonstrate these points in the following ELAC-1 failure. Assume you are the pilot not flying. You are in flight and everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Indications for aileron and elevator actuators controlled by ELAC-1 are partially boxed in amber. This means that these actuators have automatically switched to damping mode. Actuators controlled by ELAC-2 have automatically switched from damping to active mode to control the ailerons and elevators. They are not boxed on the ECAM flight control page. The ELAC-1 fault light is illuminated on the flight control panel. We can see that the first action is to reset the faulty computer. The pilot flying will ask you to perform the ECAM actions. Perform the ECAM action. ELAC-1 is now off. Continue ECAM action. ELAC-1 has not been successfully reset. The procedure requires you to switch ELAC-1 off. Continue ECAM action. After review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. A green message advises us that we have a degradation in approach capability. Note that there is loss of neither control surfaces nor maneuvering ability. You can see in the INOP Systems column that ELAC-1 and CAT-3 Dual are now inoperative. After review and confirmation from the pilot flying, clear status. ECAM completed, screens normal. We will now review other backup features which provide redundancy in case of failures. In case of complete failure of ELAC computers, the SEC-2 computer takes over the control of the elevators and the trumbable horizontal stabilizer. The roll function is still available via the spoilers. The ailerons are in damping mode. In the very low probability of SEC-2 failure, it will be replaced by SEC-1. Another possible failure is an elevator fault. In this case, the deflection of the remaining elevator is limited to avoid excessive asymmetrical loads on the tail or rear fuselage, and to reduce the asymmetry effects. The remaining surface is sufficient for normal flight. In case of total loss of normal control or hydraulic supply, the elevators are automatically set to and maintained in the neutral position. Mechanical control of the trimmable horizontal stabilizer is always available via the pitch trim wheels. For the rudder, mechanical control via the rudder pedals is always available, even in case of complete failure of the flight augmentation computers. This is mechanical backup. Summary. General rules. If a computer fails, the second computer of the same type takes over. Each primary flight control surface is supplied by at least two different hydraulic sources. An independent actuator is associated with each hydraulic source for each surface. Each actuator is controlled by a different computer. For a surface, one actuator is always in active mode, while the other or others are in damping mode. Ailerons, elevators, THS, rudder. If both ELACs fail, SAC-2 controls the elevators and the THS. The ailerons are in damping mode. If SAC-2 fails, it will be replaced by SEC-1. In case of one elevator failure, the deflection of the remaining one is limited to avoid excessive loads on the tail and rear fuselage. Mechanical backup is always available using the rudder pedals and pitch trim wheels. Let's see how the spoilers are controlled by the SEC. The spoiler control is shared by all three SECs. We will now see a spoiler fault. Assume we are in descent, speed brake extended, and no previous fault has occurred. Retract the speed brake to activate the failure. Observe left spoiler 3 indication in amber on the ECAM flight control page. These indications mean that left spoiler 3 has failed in the extended position. The SEC which controls this spoiler and has detected the fault will automatically retract it and inhibit its symmetric one on the other wing, right spoiler 3, also shown in amber. You can now observe on the ECAM flight control page that spoilers 3 on both wings are retracted and shown in amber. Note that when a spoiler has failed on one wing, the symmetric one is automatically inhibited. As a general rule, spoilers are automatically retracted when faulty or not electrically controlled. As no action is required in the procedure, after review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. A blue message advises us that we will have to calculate a new landing distance. This is due to the fact that both spoilers 3 will stay retracted when the remaining ground spoilers extend at touchdown. In certain circumstances, speed brake extension can be inhibited. In these cases, the spoilers are automatically retracted and stay in this position until the inhibition conditions no longer exist and the lever is reset. A master caution and an ECAM procedure are also triggered. Each spoiler is operated by a single actuator, powered by one of the hydraulic sources. In case of hydraulic loss, an affected spoiler will remain at its current deflection unless pushed down by aerodynamic forces. Summary. Spoiler control is shared by the 3 SEC computers. When a spoiler has failed on one wing, the symmetric one is automatically inhibited. As a general rule, spoilers are automatically retracted when faulty, inhibited, or not electrically controlled. Each spoiler is fitted with a single actuator supplied by one hydraulic source. In case of loss of hydraulic supply, an affected spoiler remains at its current deflection unless pushed down by aerodynamic forces. Note that there are neither audio nor visual warnings in this case. The title of the failure is displayed on the EWD. SFCC1 flap channel is faulty. Because the flap information is displayed on the EWD, no system page is called. The only action is to deselect the GPWS flap mode. The pilot flying will ask you to perform the ECAM actions. Perform the ECAM actions. The status page is displayed for review. Note the green messages. The first message states that number 1 engine is limited to approach idle. This means that the full power range is available, but idle is limited to the higher flight idle setting. The other message states that the flaps will be slow. When a SFCC flap channel is inoperative, the flaps are still available, but they will move at half speed. If the 2 channels of one SFCC fail, both slats and flaps will operate at half speed. You are now in the approach phase. Flaps 1 have already been extended. Now set flaps 2. Notice on the EWD that flap F and the flap triangle have turned amber, indicating that we have a flap fault. The amber F locked indication replaces the selected position to indicate that the flaps are locked. The green S and the green triangle indicate that the slats have reached the selected position. Notice the amber line. The wingtip brakes, WTB, are hydraulic devices. They lock the affected surface movement on both wings in case of asymmetry, overspeed, symmetrical runaway, or uncommanded movement. Note that they cannot be released in flight. If the flap's wingtip brakes are activated, slats operation is still possible. Should the slats wingtip brakes activate, flap extension is still possible. Notice that you are restricted to slats 2 limiting speed. After review and confirmation from the pilot flying, clear flight control. The status page is displayed for review. The required landing configuration is flaps 3, which will give maximum slat deployment. Information in green indicates that we will have the approach idle on both engines. In the inop column, the flaps are listed as inoperative. You have seen a flap-locked fault. Let's assume we have no failure. You are the pilot not flying, and we are in approach. Flap 1 has been set, and you are ready to set flap 2. Notice on the EWD that flap S and the slat triangle have turned amber, confirming that we have a slat fault. We are restricted to VFE flap 2. The action is limited to the recycling of the flap lever. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. The flap lever is back to 1. Set it again to 2. The slat recycling has not been successful. Notice that, in this case, the procedure steps stay on the EWD. you can see that we are now in alternate law. The loss of the protections is confirmed on the PFD by the amber crosses at the roll and pitch limits. The status page is displayed for review. A white Approach Procedure title shows us the procedure to apply for the approach. In this case, fuel pumps configuration, flaps, and GPWS settings. The status page confirms that the aircraft is in alternate law and will go to direct law when the landing gear is extended. Also, the approach capability is degraded to Cat 1. The flaps are equipped with the flap disconnect detection system. This system will detect attachment failure and inhibits flap operation to limit further damage. In this case, you will get an alignment fault. The procedure is similar to the flaps lock procedure seen previously. The last protection feature is the slat's alpha speed lock function. This function inhibits slat retraction at high angle of attack and or low speed. It is indicated by an alpha lock pulsing blue light on the engine warning display.